Hello and welcome. In this video we will learn about significant figures, also known as significant digits. Significant figures are essential in science because they tell us not only the value of a number, but also how precise that number really is. Let's explore what they are, why they matter, and how to use them correctly. 1. What are significant figures? In pure mathematics, numbers can be exact. But in science, measurements are never perfectly exact. Every measuring tool, whether it is a ruler, a scale, or a thermometer, has limits to its precision. Significant figures represent the digits in a number that carry real meaning about the accuracy of the measurement. They are a way of communicating certainty, so that we do not give a false impression of how precise our results are. 2. Why are they important? First, significant figures reflect the accuracy of a measurement. Second, they prevent false precision. If a digital scale reads 54.32 grams, that is precise to the hundredth of a gram. If we were to write 54.32000 grams, it would wrongly suggest the scale could measure to a millionth of a gram. Finally, they provide a common language for scientists worldwide to report data consistently. 3. Rules for counting significant figures. Let's go through the rules one by one. Rule 1. All non-zero digits are always significant. For example, the number 527 has 3 significant figures. Rule 2. Zeros between non-zero digits are significant. For example, 1003 has 4 significant figures. Rule 3. Leading zeros are not significant. They only serve as placeholders. So, 0.00456 has 3 significant figures because only the digits 4, 5, and 6 count. Rule 4. Trailing zeros in a number with a decimal point are significant. For instance, 45.00 has 4 significant figures. Or 0.300 has 3 significant figures. Rule 5. Trailing zeros without a decimal point are ambiguous. For example, 1500 could have 2, 3, or 4 significant figures depending on how it was measured. 4. Significant figures in calculations. Now, how do significant figures affect calculations? For multiplication and division, the answer must have the same number of significant figures as the factor with the fewest. For example, 4.56 times 1.4 equals 6.384. Since 1.4 has 2 significant figures, the result must also have 2, so the answer is rounded to 6.4. For addition and subtraction, the rule is slightly different. For example, 12.11 plus 18.0 equals 30.11. But since 18.0 has only one decimal place, the final answer must also have one, so the result is 30.1. 5. Scientific notation and significant figures. Scientific notation is very helpful for showing significant figures clearly. 4.5 times 10 to the power of 3 has 2 significant figures. 4.50 times 10 to the power of 3 has 3. And 4.500 times 10 to the power of 3 has 4. This avoids the ambiguity of trailing zeros in large whole numbers. 6. Examples. Let's test a few examples. 0.00720 has 3 significant figures. 3.200 has 4 significant figures. 1.0050 has 5 significant figures. And 100 could have 1, 2, or 3 depending on how it is written in scientific notation. 7. Common mistakes. One common mistake is confusing rounding with significant figures. Rounding is applied after we decide how many significant figures should be kept. Another mistake is mixing up decimal places with significant figures. For example, 0.00056 has only 2 significant figures, even though it has 5 decimal places. 8. Why this matters. In chemistry, reporting too many digits in concentrations or yields makes results misleading. In physics, reporting distances or times with the correct number of significant figures ensures that results match the precision of the experiment. And in engineering, avoiding false precision prevents errors in design and construction. Significant figures are a way of showing the precision of a measurement. The rules for counting them are clear, and they guide how we report calculations. Using the correct number of significant figures ensures scientific honesty, prevents miscommunication, and reflects the true accuracy of our work. Thank you for watching, and I hope this explanation helps you understand significant figures with clarity and confidence.